Guys, welcome back to the Distinction Factory where we make our mark. And today we are going to be practicing some Euclidean geometry, and it involves congruency and such. Today we are looking at June 2015 past paper, and it says in this question you must give a reason to justify each of your statements. It does say in the diagram below we've got PQRS, which is a parallelogram. So as soon as they tell you what type of shape you have, you're going to go and fill in the properties of that shape that you already know. So for example, because it's a parallelogram, we know that this line is parallel to this line and also equal in length. We know that this line is parallel to this line down here, because opposite sides of a palm are parallel, and this is also equal to this in length. We also know that because of these parallel lines, we can find or use our fun angles. So for example, we know that P2 will be equal to R2 because they are alternate angles to each other. Here's our little N shape that we've got. And yeah, for now we're going to use that. We also know that this angle will be equal to this angle here and those sort of things. We also do know that because it's a parallelogram, your diagonals are bisected. So we've got diagonals PR and QS. That means that this line here, let's put a highlight on it. So this is equal in length to this. And then separately, we've got this part being equal to this part here. Okay, it also says that XY and QS, or rather XS, are drawn such that XY is parallel to XS. And they have pointed that out for us here as well. The first one says, question 8.1, prove that triangle QPY is congruent to SRX. So let's see which triangles they're talking about. We're going to keep that in mind. They are saying QPY. So that's our first triangle. And then triangle SRX is coming down here. SRX. They want us to prove that those two are equal to each other. So we already have two things. We know that P2 and R2 are equal to each other because they're alternate angles. We also know that this line PQ is equal in length to SR because they are opposite sides of a parallelogram, so they have to be equal and parallel. And then we're just missing one more thing. We can't use any of the lengths. Like for example, we don't know what the length of QY is or PY. Same thing here. We don't know the lengths of those two sides. So what we can do is use some fun angles. We can find another angle that will be equal to each other. So what I'll do is, I know that I have this parallel line here. So I can then say that Y2 is going to be equal to X1 because they are alternate to each other. So I'm going to point that out to them. Question 8.1. I'm going to say that Y2 is equal to X1, and my reason for that is alternate angles. My parallel lines were given to me as QY being parallel to XS. Okay, so now because we have this angle and this angle, those are outside of the triangles, so we're going to translate it to move it inside the triangle to basically find the size of Q1, or rather Y1, and X2. So we can use angles on a straight line to solve for that. So we're then going to say that 180 minus Y2 is equal to Y1, angles on a straight line. And then we're going to do the same concept for X2. So we're going to say 180 minus angle X1 will equal to angle X2. And we're using the same reasoning there. Okay, so because those two things are equal to each other, remember X1 and Y2 are the same size. We show that to them. So they are basically equal to each other. So then we can say, therefore, Y1 is equal to X2. And now that is our third thing that we're going to use to prove congruency. So we're going to work with our triangles. whenever you're working with congruency, state which triangles you're working in. So in triangle QPY and triangle SRX, the first thing that we know is that opposite sides are equal to each other. So we're going to say QP is equal in length to RS. Opposite sides equal in a parallelogram. The second thing is that angle P2 is equal in size to angle R1 because they are alternate angles. And our parallel lines for this will be QP being parallel to RS. And then our third thing is Y1 is equal to X2 because we proved that above. So proved above. So because we have a side, an angle, we can then say, therefore, triangle QPY is congruent to triangle SRX. And my case to prove it is angle, side. All right, let's move on to the next question, question 8.2. It says that we now need to prove that X, or rather QYSX, is a parallelogram. So let's look at which shape they're talking about. QYSX. We want to prove that that is a parallelogram. Oh, that autocorrect did not work out there. So let's see what we have. So in the previous question, we did just prove that we have two triangles that are congruent to each other. That means that this line QY, let's put a little thingy like this, will be equal in length to SX because those are congruent triangles. So we have a set of equal lines and parallel. They did tell us that it's parallel as well. And that's one of the ways that we can prove a parallelogram, because as long as you have one pair of equal and parallel lines, then by default it's a parallelogram. So we just now have to write that out for them. We're going to tell them that QY is equal in length to SX. And our reason for that is proved above, or congruent triangles. And we also know that QY is parallel to SX, and that was given. They told that to us. Then we can say, therefore, QYSX is a parallelogram. And my reason for that is one pair of opposite sides equal and parallel. All right, let's go on to our next question, which says that we need to prove that ym is equal in length to mx. Now, remember that we did just prove that this is a parallelogram. And one of the properties of a parallelogram is that your diagonals are bisected. So this line yx is a diagonal of that line, and this line QMS is also a diagonal. So that means that they are both intersected at point M. By default, that means ym is equal in length to mx, as the question has asked. So now we just have to put that out into words. I will do that up here on the side, question 8.3. We're going to tell them that ym is equal in length to mx, and our reason is diagonals bisect in parallelogram QYSX. Okay, it is only 2 marks, so you just have to basically give a reason for why you're saying that they are equal to each other. All right, I hope this video has helped you guys, and I will catch you guys in the next video. Bye!